Okay, so this is the last thing we're going to talk about in this chapter, and this is another application of parametric equations. These figures, all four of them that I've got on my screen here, are examples of Lissajous figures, or Lissajous figures. And you can write all of these as a parametric set of equations where x is equal to a cosine bt and y is equal to c sine dt. And we're going to talk about how we do this. So let's talk about just the first one here. So I'm going to actually put this guy in here and crop jets down to this guy. So we're going to talk about him. And what I want you to realize is that the x coordinate is always related to cosine. And we can find the magnitude of my cosine function from my minimum and maximum x's. So we can see that I've got a minimum x of -4 and a maximum x of 4. So for my x, minimum is -4, max is 4, which means that if I were going to graph this out as a cosine function, we would know that my magnitude is half of that difference, which is 4. So magnitude is my A. So now, how would I find the period? Well, think about it this way. When t is 0, cosine is going to be at a maximum. So we're going to start here. And the easiest way to do this is to count y-axis crossings, because when x equals 0, we're counting the y-axis. So we've got 2 y-axis crossings per period. So if we count y, so we're going to start at our starting point, we're going to count y-axis crossings, and we're going to trace the whole curve until we get back to the y-axis, or back to our beginning point. So there's 1, there's 2, there's 3, there's 4, there's 5. Let's count that again. 1, 2, 3, 4, 5, 6. There we go. I knew I'd missed one. So there are 6 y-axis crossings in one full trace. 6 y-axis crossings in one full trace means my period is 3. Okay. So that means my x function is my amplitude. Actually, that's not my period. That's the inverse of my period. That's my frequency. Actually, what this is, that means that my internal multiplier is 3. And we're going to check me here in a minute. Okay, so we're going to do the same thing with my y function. And my minimum and my maximum y's are -6 and 6, which means my amplitude is 6. Now, when we do y, we count the x-axis crossings. So we start here, and I only count this guy once, okay? So 1, 2, just 2. So my period is my period is 1. Yeah, I think I was right the first time. All right, I have to check this every time. So let's try this. If this isn't right, I know how to fix it. So I'm going to check this with Desmos. And we're going to see what I get. So in my x place, I'm putting 4 cosine 3t. And in the y place, I'm putting 6 sine t. And we need to go from 0 to 2 pi. And sure enough, I got the right thing. So this is actually easier because what we're doing is we're counting the number of crossings, and that gives us our internal multiplier. Okay? So let's try the next one. Let's try number 38. And see if we can do this. Well, I know we can do this. Because what I'm actually counting when I count those crossings is I'm counting the numbers of the periods in one full trace. So this is the internal multiplier. This is the adjustment to the period that we would need. So, okay. We know that x is equal to something times the cosine of something times t. And y is equal to something times the sine of something times t. Now again, my maximum x's are -4 and 4, so that means my amplitude is 4. We start here at t equals 0, and we're going to trace all the way around and count y-axis crossings. So 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. Now we're going to do the same thing again, but we're going to count x-axis crossings. So we start with 1, 2, 3, 4, 4. So my internal multiplier is 4 divided by 2 is 2. Now let's talk about my amplitude. So my minimum y is -5. My maximum y is +5. So my amplitude is 5. So let's check ourselves here. So I've got 4 cosine 3t and 5 sine 2t. And sure enough, that is the correct shape. Okay, so now let's talk about what we would do if we've got an open figure, like either one of these bottom two, so 39 and 40. We would approach them exactly the same way. So let's just do this one. Okay, so same thing again. x of t is equal to something times cosine of something times t, and y is given by something times sine of something times t. Okay, minimum and maximum x's. Minimum x is -4, maximum x is 4, amplitude is 4. Now, we still want to start. It's tempting to start it at one of the ends, but if x is 0, or if t is 0, x is 4. So we're going to start at a maximum on the x-axis. And what we do is we count y-axis crossings, but we have to start and end on this maximum point. So we go, there's 1, and when we get to the end, we bounce back. 2, 3, 4. 4 divided by 2 is 2. Now, minimum and maximum y's. Well, minimum y is 3. Maximum y is 3. So the amplitude is 3. Now we're going to count x-axis crossings as we trace one full trace. Start at this maximum on the x-axis, because when t is 0, y is 0. So that was 1. There's 2. We bounce on the end. There's 3. There's 4. There's 5. There's 6. So this is 6 divided by 2 is 3. All right, let's check it. 4 cosine 2t and 3 sine 3t. Okay. All right, so that's the basics of Lissajous figures. It's just important that you recognize this form as a Lissajous figure, and you recognize these as Lissajous figures, and that you be able to build one from the other. All right, have fun. I'll talk to you again soon.